Okay, what's up, everybody? Today we're going to review basically converting units, but now we're going to talk about a couple new conversions. So we have mole and molar mass. Here's a quick rundown before we actually start doing some examples. So what is a mole? This is essentially what we need to understand about a mole. Um, if you And then also just to let everybody know, if you want to see this more in detail of me explaining it longer, please just go to the mole video. But quickly, the mole is basically a amount of material containing 6.022 times 10 to the 23 particles. Okay. A good way of thinking about the mole is that it's like we call it the chemist's dozen. So when you think of like eggs, right, we understand that if I got a dozen eggs, I got 12 eggs. Well, that's the same thing here, right? If I got a 1 mole of carbon atoms, right? I understand that that is 6.022 times 10 to the 23 atoms, right? So the same thing concept applies in this case. So we look over here, 1 mole equals 6.022 times 10 to the 23. This number basically is Avogadro's number, right? So that's a quick way of thinking about it. This is just Avogadro's number. He's the person that came up with it, basically. Okay. As well as another relationship I want to talk about, because once again, I want to get to the problems. So if you want the long drawn out version, please just head over to the Mo video. But we also have molar mass. Molar mass is a mass of 1 mole of atoms equals to an element. So essentially, if we look down here at three different examples, when we're thinking about molar mass, once again, that's 1 mole, right? Mass of 1 mole of an atom's element. So if I'm thinking about aluminum, I look to my periodic table, I see the average mass, right? 26.98 grams of aluminum. And I understand that this 26.98 grams of aluminum is equal to 1 mole of aluminum. Boy, that's a lot to say. Aluminum. Okay. So I also understand that that 1 mole of aluminum is equal to 6.022 times 10 to the 23 aluminum atoms. Okay. We look at carbon, the same thing applies to carbon. If I look at my periodic table, it's 12.01 grams of carbon. That's my mass of my carbon element. And I also understand that that is equal to 1 mole of carbon, 1 mole of carbon. So we can see, right, this is showing us two conversion factors. All right, three different numbers, two conversion factors we're going to have to use here. So breaking down this example one more time, we got 12.01 grams of carbon. We got 1 mole of carbon. Once again, this is a conversion factor here. This is a conversion factor. So if I look at my periodic table, I understand that if I see that mass number, once again, is the average of all my isotopes. So in this case, that number is going to tell me the mass of this element, which happens to be carbon. There's 12.01 grams of carbon. I also understand now, right, with our mole conversion factor here, that for every 12.01 grams of carbon, I have 1 mole of carbon. Okay. Now, this is also saying that for every 1 mole of carbon, I have 6.022 times 10 to the 23 carbon atoms. So we can see we got three different numbers, but we have two conversion factors here. 1 mole of a carbon is equal to 12.01 grams of carbon, and 1 mole of carbon is equal to 6.022 times 10 to the 23 carbon atoms. So we can see already now, right, that moles are going to be very important. Okay. So now let's just get to some examples. There we go. All right. So once again, if you see the problems right here, definitely feel free to pause me. Feel free to pause me to do these problems. But let's get into it. All right. So how many moles and atoms are there in 10 grams of aluminum? So we're starting off with 10 grams of aluminum. We need to convert them to moles and atoms. We need to convert it to moles and atoms. How do we do that? Well, let's see. First thing, I'm going to convert my grams to moles. Let's break this down here. So y'all got the answer. Great. Let's understand how we got this answer here. So we start off with 10 grams of aluminum. Okay. And then once again, notice it's still the same thing, the same process of us getting to our next unit is dimensional analysis. I told y'all it was not going away. It's popping up here again. So 10 grams of aluminum. How do I go from grams of aluminum to moles of aluminum? Well, I have to use molar mass. So once again, let's talk about molar mass. Molar mass is a mass of 1 mole of atoms of an element. So we look over here, right? I'm going to use this conversion factor. 26.98 grams of aluminum equals to 1 mole of aluminum. So we're setting it up like this. All right. I get this number from my periodic table. This is where I'm getting this number here, y'all. So my grams cancels out. Grams of aluminum are gone, completely gone. And now I'm left with on the top moles of aluminum. So guess what I have to do here? I have to divide 10 divided by 26.98 is 0.371 moles of aluminum. Okay. And just like that, in one single step, I was able to go from grams to moles using keyword here, molar mass. Okay. So we can always figure out the molar mass of a given element just by looking at the periodic table. All right. We need to get that in our heads. That's how we're going to find the moles of an element looking at the periodic table. Now, now that I'm in moles of aluminum, how do I get to atoms? How do I get to atoms? I'm going to do this. So now I'm in moles of aluminum. I'm going to use that to convert to atoms of aluminum. And I'm doing that by using Avogadro's number. As mentioned before in the previous slide, we said that 1 mole, right, is equal to 6.022 times 10 to the 23. So in this case, 1 mole of aluminum is equal to 6.022 times 10 to the 23 atoms of aluminum. Okay. So notice our two conversion factors we're using here. Avogadro's number, molar mass. Okay. So using Avogadro's number and this conversion factor, my moles cancel out. I'm in atoms of aluminum. Then I just multiply across and I see that for part B, I get 2.23 times 10 to the 23 atoms of aluminum. Okay. As our B answer here. So before I move on, I just want to make sure we understand this key essential part. This is the breakdown, y'all. In order to go from grams to moles, we have to use molar mass. Where do we find our molar mass? In this case, you got to look towards the periodic table. Using this conversion factor will help me cancel out my grams, leading me to moles. Okay. Also, remember that this is a conversion factor. So if you're going from moles to grams, what do you have to do? We're going to have to use molar mass again. Okay. 1 mole equals a certain amount of grams. Next, if you're going from moles to atoms, okay, in this instance, you got to use Avogadro's number. Avogadro's number is 6.022 times 10 to the 23 atoms of aluminum. Okay, and that's going to be equal to 1 mole. Two key conversion factors going forward, y'all need to understand. Let's move on to the next one. How many lithium atoms are there in 3 grams of lithium? So we're starting off with 3 grams of lithium. Okay. And we need to get to atoms. So notice, right? Key thing is, how do we go from grams to atoms? Dr. J, you didn't show us that. You showed us two conversion factors, right? You didn't show us how to get from grams to atoms. Well, I did. You just have to think about how you're going to get there. All right. So let's look at this. I got 3 grams of lithium. In order to go from grams to moles, I'm going to go from grams to moles. I'm going to go from grams to moles. So I'm going to go from grams to moles using molar mass. Okay. So in this case, the mass of my lithium is 6.94 grams. Where do we get this number? Periodic table. Okay. We got that number from the periodic table. And once again, we understand that 1 mole equals to a certain amount of grams for that given element. Okay, that's molar mass. So my grams of lithium cancels. I'm left with moles of lithium on the top. However, it's asking me to go to atoms. How are we going to get to atoms? Well, if I'm going to atoms, I'm going to use Avogadro's number. So Avogadro's number, once again, is 6.022 times 10 to the 23. And we understand in this case, in our conversion factor, 1 mole equals Avogadro's number. So Guess what happens? I'm going to set up my conversion factor to cancel out my moles of lithium, atoms of lithium on top. And guess what happens to all my old units? They cancel out. All right. The same thing with dimensional analysis. We're just canceling the units out as we go. Cancel, cancel. Now we do our math. Okay. If you didn't see the previous video or any of my previous videos, understand that there's two ways you could do math. You can either do 3 divided by 6.94. That's the answer. Then you multiply by this answer. That's perfectly fine. Or you could just multiply across your numerators and denominators and divide at the very end your numerator and denominator. Okay. Either way will give you the same answer at 2.6 times 10 to the 23 atoms of lithium. Okay. That's what we get here. Key thing, right? In order to go from grams to moles, we use molar mass. And if I need to get to atoms, I got to use Avogadro's number. Notice a common key unit is moles. So we're going to be using moles a lot in chemistry. Let's look at this last problem right here. How many milligrams are in 6.022 times 10 to the 23 atoms of gold? Once again, how many milligrams are in 6.022 times 10 to the 23 atoms of gold? Did y'all hear that? I don't know if you heard that. That was a How many milligrams are in 6.022 times 10 to the 23 atoms of gold? So, what are we going to have to do here? Please pause me right now. Please try to do this one right here. If not, let's go. So notice this time we're starting off with atoms of gold. So how many milligrams are in 6.022 times 10 to the 23 atoms of gold? So we're in atoms of gold and we need to figure out how to go to milligrams this time. So I'll start off with my given. All right, we start out with this 6.022 times 10 to the 23 atoms of gold. Now, the next thing I'm going to do is I'm going to convert it to moles because I know that moles is like my middle ground. All right, it's going to help me go from either atoms or grams. And in this case, right, that's great because I can go to grams and then I can go to milligrams. All right. So it's like a puzzle, y'all. We have to really think about, okay, what can get me here and then what can get me there. All right. If you don't know that one conversion factor, for doing it just in one step. In this case, that's not the case here. All right. So in order to go from atoms to moles, I use Avogadro's number. Notice that Avogadro's number, once again, is 6.022 times 10 to the 23. So we set this equal as our conversion factor. 1 mole of gold equals to 6.022 times 10 to the 23 atoms of gold. All right. So my atoms of gold are cancel out here. We're left with moles of gold on the top. Now, what do we do? I need to take my moles of gold, right? Right? And I need to convert that to grams. Now, how do we convert moles to grams? Molar mass. Yes. Thank you in the back who said molar mass. So we got, for this case, a molar mass of gold. We're going to set our 1 mole of gold on the bottom to cancel out our units here, right? And we got our grams on top. Now, where do we get this 196.97 from? We got that directly from the periodic table. That's exactly where we got that from. So once again, we get the molar mass from the periodic table. So now, moles are canceled, atoms are canceled. Now we're in grams of gold. What do we need to get to? Milligrams. So in order to go from grams to milligrams, we're going to have to use this conversion factor here. For every 1,000 milligrams, there's 1 gram. Okay. So now my grams are canceled out. I'm left with milligrams on top. We do our math, and what we're going to see is I get 196,970 milligrams of gold. Okay. So once again, this is a great problem to really digest and look at, y'all, because we had to go from atoms of gold to moles of gold in order to cancel out my atoms of gold. Then I had to go from moles of gold to grams of gold to cancel out my moles of gold. And then that's not it. I had to go from grams of gold to milligrams of gold. So in this case, I use three conversion factors to help me get to milligrams. Okay. Like I said, y'all, this is just a big old puzzle that we got to figure out. Critical thinking. Ain't doing those. Yeah. All right, so we even got more problems. You know what I'm saying? I'm giving y'all so many examples right now that you should be able to do this. Okay, so let's spice it up a little bit. Shout out to Ice Spice. All right, so calculate the amount of copper. Y'all I'm thinking that. What's that? Thought I was a munch. Man, now that's gonna be stuck in my head. All right, calculate the amount of copper in moles. Okay, the key thing is we got to figure out the copper in moles. And they give us, in this case, 30.4 grams of pure copper. This case, let's put it in three cifics this time. Let's put it in three cifics. So how do I go from grams to moles? So in order to go from grams to moles, all right, grams to moles, we're going to use our molar mass. So in this case, 30.4 grams of copper, you multiply that by the molar mass of copper. The molar mass of copper is 1 mole of copper equals to 63.55 grams of copper. All right. We get this 63.55 grams of copper directly from the periodic table. Same stuff, y'all, every single time. We're getting the molar mass from the periodic table. Okay. Now, grams cancel out. Moles is on top. We get our final answer here. 30.4 divided by 63.55 is 0.478. It's three significant figures. So this is the reason why I'm using three here. Significant, significant, significant. Okay. Look at the next one. What is the mass in kilograms? What is the mass in kilograms? Now, in this case, all right, we got to get to kilograms, but they give us something in atoms, right? Nickel atoms. We have 5.5 times 10 to the 27 nickel atoms. All right, do not let this atoms confuse y'all. Okay, do not let this confuse you. All right, let's break this down. How we go from nickel atoms to kilograms. So we have our given 5.5 times 10 to the 27 nickel atoms. In order to go from nickel atoms to kilograms, we should understand that we have to get to moles. Think of moles as being the middleman, right? You need a middleman for a lot of stuff, if you don't want to do something. So moles is our middleman. They're going to help me go from atoms ultimately to grams in some type of fashion, right? So in this case, that middleman conversion factor, right, is right here. In order to go from atoms to moles, we're using Avogadro's number. 6.022 times 10, this is raised to the 23. All right, so this is not 1,023. This is 10 raised to 23. Shout out to LeBron James. Okay. All right, so we got atoms cancel out here, and we're in moles of nickel on the top. Okay, moles of nickel is on the top. So my atoms are canceled. Do we see this? Our atoms are going to be canceled. Now we're in moles of nickel. So since I'm in moles of nickel, I understand I need to ultimately get to grams. What is going to help me go from moles to grams? I heard it. I heard it back there. All right, molar mass. That is what we're going to have to use. Okay. All right, molar mass. So for every 1 mole of nickel, there's 58.69 grams of nickel. Okay. So our 1 mole of nickel cancels out here. And now we're in grams of nickel. And once again, just to remind everybody, where did the grams of nickel, where did this 58.69 come from? The periodic table. Okay. The periodic table. We're getting everything from the periodic table. Okay. If you can read the periodic table, I'm telling y'all, chemistry is a lot easier. Okay. If you cannot read your periodic table, it's going to be hard. It will be hard. So let's just review so far what we all done. We went from nickel atoms to moles of nickel using Avogadro's number, canceling out those atoms. Now we're in moles of nickel, and in order to go from moles of nickel to grams of nickel, we use molar mass, canceling out those moles of nickel. Now I'm in grams of nickel, but it's asking me, how do you get to kilograms? Well, for every 1,000 grams, there's 1 kilogram. So my grams cancel out here, and now I'm in kilograms. And doing some math, as I mentioned earlier, right? You can do it in multiple ways. We're doing your math, multiplying and dividing. I see that I'm going to get 536 kilograms of nickel. Okay, that's a little cutoff right there. If you got any questions so far, definitely feel free to leave it in the comments. Okay, let's look at this last one. Let's look at this last one. How many carbon atoms are there in a diamond? Pure carbon. All right. With a mass of 55 milligrams. So notice in this case, think about what we have to do here. Think about what we have to do here. I want y'all to pause me, do something, whatever. But just think about how we are going to go from milligrams to what is it asking for? Carbon atoms. So already in our head, we should be thinking, okay, I'm in milligrams, and I know some type of fashion I had to go from grams to moles because I understand that moles is my middle name, my middle, man, my middle person from grams to atoms. So I'm in milligrams. I have to somehow figure out to get to moles, and then when I'm in moles, I can then go to atoms. Let's show what we did here. So I'm in milligrams of carbon. I convert my milligrams to grams first. So there's 1,000 milligrams for every 1 gram. Now that I'm in grams, I then, right, have to use another conversion factor. That conversion factor is molar mass because I'm trying to go from grams to moles. Okay, once again, I use molar mass to help me go from grams to moles. So now, right, my milligrams cancel out. Cool. My grams are cancel out. Cool. And now we're in moles of carbon. So how do I go from moles to atoms? Last thing, using Avogadro's number. Avogadro's number, 6.022 times 10 to the 23 carbon atoms, which we see here. Guess what happens to my moles? They cancel out. All right. Dimensional knowledge, y'all. It's all about canceling old units. So I do my math, and what I'm going to see here is that I get 2.8 times 10 to the 21 carbon atoms. Okay. Carbon atoms. A couple different things here. Just to point this out. Be careful with your math for these type of problems. Especially when y'all are using it, y'all calculator. I highly suggest to put everything in parentheses. Put everything in parentheses. For example, if you do not put this in parentheses, it will recognize this as multiplying this and then multiplying this. So that's a whole different thing. That's going to jack up your whole answer. Just put everything in parentheses. So put that in parentheses, right? whole number in parentheses when you go to do your math. Cannot stress that enough. That will throw everything off. All right, here's the last problem I'm going to do with y'all. Here's the last problem I'm going to do. So this problem is a gigantic one. Shout out to Willy Wonka. You know what I'm saying? So a gold medal goose egg was left at Willy Wonka's chocolate factory, and it has a volume of 4.5 times 10 to the negative 6 meters cubed. That's a big egg. Or is it a big egg? That's the question. What is the mass of the egg in grams? How many gold atoms are in this egg? And there's a helpful hint of the density of gold is 19.3 grams per centimeters cubed. Let's do this one. So, a couple different things we have to think here, right? We have to think about this goose egg, okay? And we know the volume, 4.5 times 10 to the negative 6 meters cubed. All right, so we know the volume. However, that's the only thing I really know besides the density. And it's asking me to go to mass. So this is a big hint. Anytime that you got to go from a volume to a mass or a mass to a volume, probably going to have to use density in some type of shape or form. Okay. That's the reason why density is here. You got to use that in some type of way to help you go from one unit, in this case, a length unit to a volume unit, or volume unit to a length unit, or mass unit in this case. All right. So let's look at A. Let's just focus on A. What is the mass of the egg in the grams? So how am I going to go from, in this case, my only given is meters cubed. How am I going to go from meters cubed to grams? So first thing we have to do here is think about density, right? Density is the mass over volume. If I rearrange that and solve for mass, all right, that means that density, if you multiply density by the volume, you will have a mass. Okay, that's great. You know, we had to do some algebra here. Okay. So if I multiply density by volume, I can have my mass. So this is going to be very helpful for part A here. Two ways to do this, y'all. Two ways. You can either convert your density, in this case right here, to grams per meters cubed. So in this case, changing our meters cubed. Now, well, we'll talk about the Y in a bit as far as Y. Or you could convert your volume to centimeters cubed. Let's show one of these versions here. So let's say that I have 19.3 grams of centimeters cubed. All right, that's our density in this case. And let's say I want to convert my density to grams per meters cubed. All right. So if I convert that to meters cubed, it's going to look something like this. All right. In this case, grams per centimeters cubed times this conversion factor. In order to go from centimeters to meters, we have to use this conversion factor. There's 100 centimeters for every 1 meter. Now, will my centimeters be canceled with centimeters cubed? No, we have to cube the entire conversion factor here. So this centimeters becomes centimeters cubed. But as well, understand what happens to my meters. It becomes meters cubed. That's very important for what we're trying to do here. So when that happens, you also have to pay attention to your numbers. So this 100 is not just 100 when it comes to multiplying. This is 100 cubed. Okay, so this is 100 cubed. So if I do my math correctly, and if I do 19.3 times 100 cubed, right, with my, in this case, centimeters cubed being canceled, grams staying the same on the top, because in this case, we just bring that on over, right? The grams come over, and guess what happens to my centimeters cubed? They cancel, and my meters cubed is on the bottom here. So my units are good. Do my math, This is the number I get here. Now, now that I have this number, which guess what this new number is? It's my mass over volume, right? This is my new density. So I'm going to use this density and I'm going to multiply it by the volume that we have. So notice why we went from, right, centimeters cubed to meters cubed. We did all of this just to cancel our meters cubed. That's the reason why we did this, y'all. So when you go to multiply, right, in this case, guess what happens? Since the meters cube is the only bottom and my meters cube is on the top, they will cancel out. This is dimensional analysis at its core. So if I multiply my number here by my number here, I get 86.85 or 87 grams of gold. Here's the other way. So let's say I got my volume here. Cool is 4.5 times 10 to the negative 6 meters cubed. All right. And I have a density here. I got this equation. I know that if I multiply density by volume, I know I'm going to get a mass. So let's say I just convert my volume to centimeters cubed because my density is in centimeters cubed. So in order to convert my volume to centimeters cubed, I'm going to have to cube root this entire conversion factor. 100 centimeters for every 1 meter. My meters cubed cancels out. My centimeters cubed is what I want. We multiply across, I get 4.5 centimeters cubed. Now I can place that in my equation and notice, y'all, depending how you want to do it, one way looks a lot more easier than the other right now. 19.3 times 4.5, that gives me the same exact answer at 87 grams of gold. Y'all just saw how we did that, right? I did this 2 different ways, same answer. First way, I converted my density to grams per meters cubed using this same equation here. Second way, I converted my volume to centimeters cubed using this same equation here. Okay. Just want to make sure we understand that. If you don't, please let me know. Now, once we figure out the mass, right, of our egg, which in this case, this is like I said, this is a pretty big egg at 87 grams. Like, come on. That's pretty big. And that's just gold. So we got 87 grams. I mean, I guess depends on what you say big is. But 87 grams. All right, so 87 grams. We need to convert that to atoms. How are we going to do that? Avogadro's number in moles. Need y'all to remember those 2 things. So here are the 2 key conversion factors that you need to pay attention to. If you don't remember anything else, pay attention to this last problem. 87 grams of gold multiplied by the molar mass. Once again, how do we get this conversion factor? We look at our periodic table because I understand that for every 196.97 grams of gold, I have 1 mole of gold. So my grams of gold cancels out. I'm left with moles of gold on top. And I need to get to atoms. So I'm going to multiply that by Avogadro's number. 1 mole equals 6.022 times 10 to the 23 atoms. My moles cancel out. My grams are gone. I'm left with atoms on the top. Now all I have to do is multiply and divide, and I get 2.7 times 10 to the 23 atoms of gold for my final answer. Okay? So everybody, that's it. That is essentially it. Key thing you want to pay attention to is you got to be able to do algebra first off, right? Because if you were never going to be able to isolate the variable, this is going to be a hard problem regardless. So you have to be able to isolate variables and do algebra. Once you figure out, okay, you know how to find the mass using density, we got to figure out, well, how do I convert either my density or volume to cancel out my units in order to get to my mass, which we did over here. Once we determine our mass, then all we have to do is convert to atoms, which we use molar mass and Avogadro's number to do that. All right, y'all. So please go ahead, do some problems, and let me know if you have any questions. Thanks for listening to this episode of Don't Be Scared. We hope you found this discussion valuable, helpful, and informative. You can reach us through our website, social media, or by leaving a review on your favorite podcast platform. 5 stars, y'all. And don't forget to check out our resources and services at Don't Be Scared, where we help organizations and individuals engage with science and pursue their dreams in the field.